Hello, welcome you all. Continuation of our discussion on bending moment and shear force diagram. So I think I have solved sufficient number of problems on cantilever. Sufficient subject to or within the limitations of the time availability what we have, how much you can afford for this module. I wish you to solve some more problems and you can come up with the doubts if at all you get it. And today I shall move on to another problem, that is another beam, another type of beam. Okay, please go through the beam. What do you find? So it is definitely overhanging beam. The beam portion is there beyond the support, therefore it is a overhanging beam. And what type of overhanging? It is the right hand side only overhanging. Overhanging is only on the right hand side, right hand side. So one more small observation. We have defined overhanging beam also. It is basically a simply supported beam. Simply supported beam shall have both the roller bearings, roller supports, or one roller support and one hinged support. But here in this diagram, both the supports have been given as hinged. I think one of them should have been roller. Okay, so these hinged supports, you know that they are going to provide the supports reactions in the form of the vertical and also horizontal. Since the external loads happen to be only vertical loads, and therefore the reactions, the kind of reactions these supports are going to offer only vertical. If you take it, I think probably even if it is like this, absolutely no problem. Even if you have horizontal support here, it is not required because there is no horizontal force, external force. Similarly here also the horizontal thing is not required. Both of them both the supports are as good as the roller supports, because we are going to have reactions only in the vertical direction. The first thing what we do for cantilever is replace the support by the reactions. So I should replace this support by what is called as, I shall call a reaction. I have a vertical support here and this I call it as say RA, the reaction A. And similarly I shall replace this support and by one vertical force and I shall call it as RD. Okay, RA and RD are the reactions offered at points A and D. This is the overhanging beam. Okay, so all that, everything fine. This is 2.5, this is 1.5, this is 1 and this is 1 meter. So if someone asks you, what is the span of this beam? What is the span of this beam? What is the meaning of span? Span is the distance between the two consecutive supports. Here I have only two supports. This is one support, this is another support. What is the distance between these two supports? 2.5 plus 1.5, 4 plus 1. 5 meter is the span of the beam. Please remember, it is not the entire length from here to here. This is 6. From here to here is 6. Correct? No? 2.5, 1.5, 4, 5, 6. 6 meters is the length of the beam. What is the span of the beam? Span of the beam is only 5 meters. Please know that. Okay, so now the first thing what we need to do is what is called as determine the reactions. Determine the reactions. Okay, so by applying what? By applying equilibrium conditions, the total upward force RA plus RD is equal to the total downward force 20 plus 15 plus 10. Okay, 35, 45 kilonewton. RA plus RD is equal to 45 kilonewton. This is one of the conditions. Then take moment about sigma m about any point. Say I shall take moment about point D. I shall take the moment due to all the forces about point D and equate it to 0. I am applying the equilibrium conditions. Let me start with this RA. So the moment due to RA about point D. Okay, that is nothing but I shall write it as RA multiplied by what is the distance? 4, 5. This 5. RA into 5. When you write it, please remember, unknowingly you have made a sign convention. Okay, what is that sign convention? You have written this plus. You have written this plus. that means this moment is positive. What is this moment? The moment due to RA about D is clockwise. Clockwise moment is positive. Okay, then let me come to the next one, 20 kilonewton. The moment due to 20 kilonewton about D. So first of all, it is anti-clockwise, therefore it is minus 20 into what? 20 into 1.5 plus 1, 2.5. Then the moment due to 15 about D is also minus 15 multiplied by 1. Then the moment due to RD about D, that is 0. And the next one, the moment due to 10 kilonewton and about D, please remember this also is clockwise, and our clockwise moment is positive, therefore it is plus 10 multiplied by 1, the whole thing is equal to 0. So simplify this. So this is equal to RA is equal to 20 into 2.5 plus 15 into 1 minus 10 into 1, the whole thing divided by 5. This is equal to, okay, 20 into 2.5 is 50, 50 plus 15, 65, 65 minus 10. 65 minus 10 is 55, 55 divided by 5 is 11. RA is 11 kilonewton and therefore RD is equal to 24 kilonewton. Okay, replace this. Now RA is going to be, though I call it as RA for all practical purpose, I know what is its value. What is RA? RA is 11 kilonewton. This is 11 kilonewton. This RD is 34 kilonewton. Once you do this is what? Okay. So now all this is our starting preliminary things required. Okay. With respect to the cantilever beam, what I used to do. So now we have reached a stage. After calculating all the reactions, now you are in a position almost same level. What is to be done? Choose a reference. Choose a reference. So reference you have to select. So let me choose A as a reference. I shall choose A as a reference. Okay, this is my reference. This is my X. This direction is my X. Okay, so then what are the portions? What are the different portions you have to analyze? What are the portions? One is AB, the portion AB. The other one is BC, the portion BC. Then the other one is CD. And the other one, the last one is what you call as DE. AB, BC, CD, DE. So all these portions. So now let me make filtrations here. So I shall draw a horizontal line and call this as B equal to 0. Similarly, to draw bending moment diagram, draw another horizontal line and call this M equal to 0. Okay? So now everything ready. Now let me take one by one portion. So what is that portion? Start with portion AB. Portion AB. So A is the reference. Number one, portion AB. Okay, draw the free body diagram. So this is my A. This is what is RA, that is nothing but 11 kilonewton. The name RA is not important for me. How much force is there, that is important for me. Okay, so this is A. Please remember this is not B. And this distance is what is X. This distance is X. This is where you have to cut it. B is beyond this. And therefore, what is the range of X? Let me write down. X is 0, the smallest value. And the largest value is 2.5 meters. The range of X is between 2.5, 0 and 2.5. This is the only force. Even 20 kilonewton is acting at B. So I have now reached B. Therefore, 20 kilonewton is also not going to come. Okay, now, so at the section where you have taken, you have taken section here, and I am taking the left hand side portion. Please go back to your sign convention. Okay, you take a section, and if the portion of the beam what you are considering is left hand side, then the positive shear force, this is my positive shear force. my bending moment. This is my positive bending moment. So any beam which bends like this, if this is a beam, if it bends, if you apply this way positive bending, this is called as positive bending moment. This is the beam, you have to bend it like this. This is my positive bending moment. This is Mx, that is Vx. Don't worry about the sign convention, as long as you are consistent, it is alright. So your values will remain same even if you take the different sign convention, absolutely no problem. Okay, now find out what are the magnitudes of Vx and Mx. For that, apply equilibrium conditions. I start with Vx. I am writing Vx the first term. That means this is my positive. So I start with Vx, this is bending moment. I have another 11 kN, it is upwards and it is minus. It is 11. This is equal to 0. Therefore, Vx is equal to 11 kN. So what are the observations? The shear force is constant. Shear force does not vary. Okay? So therefore, between A and B, shear force is constant and 11 kN positive. So at A, I have a shear force which is 11 kN. And at B also I should have the same thing. And therefore, this value is also 11 kN. So this is the positive, this is the shear force diagram for the portion AB. Now let me continue for the bending moment portion. I start with Mx I have written here. Unknowingly I have made already sign convention. What is that? This Mx is positive. What is this? Anti-clockwise. Any anti-clockwise moment about this section is positive. Any clockwise is negative. Okay, Vx will not have any moment. You see further, I have this 11 kN about this. This is clockwise. Therefore, it is minus how much? It is 11 into x. This is equal to 0. So, therefore, Mx is equal to 11x. So, what is observation? Bending moment between A and B is not constant. Bending moment between A and B is varying. Bending moment between A and B varies linearly. Straight line variation or straight line variation, 2 points are enough. Bending moment at A and bending moment at B. For A, what is the value of x? X is 0. Therefore, this is 0. For B, x is 2.50. That is 11 into 2.5. So, is it 27.5? 27.5 kilonewton meter. So, therefore, come back and draw it here. So, at A, it is 0. And at B it is positive 27.5. Write this 27.5 kilonewton meter, and in between it is a straight line variation. Okay, so the portion for bending moment diagram for AB is over. Now let me go for what? For the portion BC. So for the portion BC, when I start, this 2.5 will come here and this will be different. What is that? 2.5 to plus 1.5. Okay, if you are not convinced, then draw the diagram and then you can come. No problem. Okay, so I take a section between portion BC, take a section between B and C. So somewhere here and draw it. It looks like this. So this is my A. And somewhere here, this is my B, and this is not C, please remember. And I have 11 kN. And this distance is what is x. This is where the section is. And at B, I have one force now. This is 20 kN. Okay, at the section where you have, okay, you will have a shear force, and the positive shear force is this. And this is the positive bending moment. Any doubt about this? Okay. So because you have taken a section here, and for analysis I am taking the left hand side portion. Go back to the sign convention, what I had told. Okay. So everything is fine. Any other force? Nothing. Very simple. We have to start downward force is positive. This is moment. This 20, this also is downwards, therefore this also is plus 20. Then proceed further. 11, this upwards minus 11. This is equal to 0. Therefore, Px is equal to 20 minus 11 is 9, and take it to the other side, it is minus 9. So shear force between B and C is constant, it is not varying, and its value is 9 kilonewton. Okay, so between B and C, shear force is 9 kilonewton. So I shall draw a line, 9 negative, 9 kilonewton. This length is slightly smaller than this, and throughout the length it is constant, and here also this also is 9 kilonewton. So this is the shear force diagram. Now let me go for what is called as bending moment diagram. mx start with this, anti-clockwise is positive, this is 0. Then the moment due to this 20 is also about this, also is anti-clockwise, therefore it is plus 20 multiplied by how much is this distance? So this is x, I know that this is 2.5 meters, and 20 into x minus 2.5. This is x, this is 2.5, this distance is 20 into this distance, x minus 2.5. Then this 11, it is opposite to this, therefore it is minus 11 into x. This is equal to 0. Therefore, mx is equal to 11x minus 20 into x minus 2.5. So observation, bending moment between B and C is not constant. Bending moment between B and C varies. Bending moment between B and C varies according to a straight line, linear variation, because x raised to 1, x raised to 1. So therefore, to draw a straight line, 2 points sufficient. Bending moment at B, bending moment at C. Bending moment at B, for that substitute x equal to 2.5. This, that is 11 into 2.5, that is nothing but 27.5 kilonewton meter positive. Okay, for C, bending moment at C, substitute x equal to 4. 11 into 4 is 44, minus 20 into 4 minus 2.5 is 1.5. Okay, so this is equal to 20 into 1.5 is 30. 44 minus 30 is 14 kilonewton meter. So it is a straight line, therefore you can easily complete it now. Okay, so what is the bending moment at B? Bending moment at B is 27.5, that is this value only. Then what is bending moment at C? It is 14, it is almost half, little more than half. Accordingly, if whatever the line you have drawn, 14 is almost half, that is that much. So how is the variation? It is a straight line. So this is the variation of bending moment for the portion BC. I hope it's clear. Now portion BC is over. What is the next portion? The portion CD. The portion CD. For the portion CD, now this becomes 4 and this you have to find out. So this becomes 5. Okay, so between the C and D, and you can have it now. So you have A, you also have B, you also have C, and this is the portion where you have cut it. D has not been reached yet, and you have what is called as 11 kilonewton. At B you have a force which is 20. At C you have a force which is 50. And from here to here is x. And this distance is 2.5 meters. I require to know what is this distance from here to here. This distance is x minus 2.5. And I know that this distance is 1.5. from here to here, and I also require later on this distance. How much? This is x minus 4. Okay, so now what is the shear force? Positive Vx, bending moment like this. Very simple. Because you know what are the marks for this? One full question, 16 marks. Okay, the question paper pattern is each question carries 16 marks, and what we are solving is 16 marks question. Okay, very simple. Vx, start with this downwards positive. So see, you have 15, that also is positive. Then 20, that also is positive. Then you have 11 upwards, therefore it is minus, therefore this is equal to 0. So therefore Vx is equal to 35, 35 minus 11 is 24, 24 goes to the other side, it is minus 24 kilonewton. So shear force between C and D is constant, does not vary, and its value is equal to minus 24. So therefore come back here. Okay. So at C, so this is A, this is B, this is C, and have here C. This is 24. So I shall write it as 24, and throughout it remains same. This also is 24. So this is the shear force diagram. So now bending moment diagram. So it's very mechanical, same procedure, but you need to exhibit lot of formations because you have more and more portions and more complex problem is nothing. It is not difficult. It is going to take more time, nothing else. So that length time you have to be very patient. So here next, start with next. This anti-clockwise is positive. The moment due to 15 is also anti-clockwise. So therefore it is plus 15 into distance. How much? X minus 4. Then proceed. 20. The moment is also anti-clockwise. Therefore that also is positive. 20 into x minus 2.5. Okay, over. Now 11. The moment is opposite. Minus 11 into x. 11 into x is equal to 0. So therefore mx is equal to, okay, maybe I started 11x minus 20 into x minus 2.5 minus 15 into x minus 4. Observation. Bending moment is not constant between the portions C and D. Bending moment is varying between C and D. Bending moment varies according to a straight line, linear. Okay, very simple. Linear, straight line. Bending moment at C and bending moment at D. 2 points you join them, and then you will get the bending moment for that portion. For C, x value is 4. X value is 4. That means this term is not there. So it is 11 into 4 minus 20 into 4 minus 2.5 is 1.5. This term is 0. Okay. So 20 into 1.5 is 30. 44 minus 30 is 14. 14 kilonewton meter. And bending moment at D, what is the value of x? X is 5. So 11 into 5. 11 into 5. Plus minus 20 into 5 minus 2.5 is 2.5 minus 15 into 5 minus 4, this is 1. Okay, this is 55 minus 20 into 2.5 is 50 minus 15. Okay, 50 minus 15, that is 55 minus 50 is 5. 5 minus 15, this is minus 10 kilonewton meter. Okay, so let me draw this now. Okay, what is the bending moment at C? Bending moment at C is 14. I forgot to write this. This is 14 kilonewton meter. The same value, this is value. And what is the bending moment at D? It is minus 10. So this is 14 and this is 10. This value is 10 kilonewton meter negative. And how is the variation? It is straight line. safety valve. And this point, this is called as point of contraflexure. Please remember, contraflexure. Contra means opposite, flexure means bending moment. The portion which is subjected to different bending moment. Say at this section, please, it is not the bending moment diagram. I have to go back here and here. This portion is what is called as point of contraflexure. A portion of the beam on either side subjected to different sense of bending moment. Sense means direction. Different direction bending moment. That section is called as point of contraflexure. Okay, point of contraflexure, and you have been asked to find out, locate the contraflexure. Where is it? So for that purpose, let me take this value as some y. So this length is y, and how much is this length now? I know that this entire portion, go back here, it is 1 meter. So if this is y, then this is 1 minus y. Okay, so this value is y, and you know this is 10. This is y, and this is 10. This is one triangle, and similarly this triangle. This is 14, and this length is 1 minus y. Okay, so now y divided by 10 is also equal to 1 minus y. 1 minus y divided by 14. 1 minus y divided by 14. So therefore, simplify this. This is 14y is equal to 10 into 1, 10 minus 10y. Take this 10y this side, it becomes 24y. 24y is equal to 10. Therefore, y is equal to 10 divided by 24. Okay, this 5 and 2 12 are. So this is equal to 416 meters. 416 meters. That is nothing but this. And therefore, so this ultimately I want this distance from here to here. Okay, you have to say that point of contraflexure is at a distance of so much from point A. I would like to say that. So how much is that? I know that from A to D 2.5, 1.51. How much? 5 meters. 5 minus 0.416. 5 minus 0.416. That is nothing but 584 meters. This is what? What is this? What is this? This is a point of contraflexure. So because of shortage of space here, I have written C of point of contraflexure. That means the opposite distance. Okay. So now I have drawn this, and what is the next one? Same thing between D and E. The portion for D and E. So I want you to complete it. Okay. So maybe the completed diagram I shall post it. I shall put it. I want you to take out for the portion DE. What is to be done? DE. Take a section between D and E. Then draw the portion from here to here. Then you have so many forces. This, and also this. Then Vx. Then Mx. Then take the moments. Apply the equilibrium condition. Get Vx, etc. So I want you to complete this portion. Okay, probably this is going to be the line, or you check it, I'm not very sure. Check this and also draw. It's called as this. I hope you'll complete it. So if you have any doubt, you can ask me, and any doubt, I'll be very happy to clear it. Thank you. Take care.